That's cool, right?
So if you think what we've done up until now is redneck, this is going to take the cake. Sick.
I wanted to take a quick second while I drove over to Adams to say thank you to everyone. You all helped push me over YouTube's monetization threshold. First and foremost, I want to thank my original subscribers for sticking with me through this, because this channel was mad cringy at the beginning, and I'm not even going to try to sugarcoat it. So thanks for hanging out with me while I found my voice on YouTube. Second, I want to thank Adam. Thanks, man. He's the one that kind of put out the message on his channel to kind of see if some people wanted to come over and see what I'm about. And that definitely, there was a spike for sure. And it helped push me over the hours limit for monetization on YouTube. So thanks, man. I appreciate it. And then that being said, thank you to Adam's subscribers that jumped over here to see what I'm about. It really helped. It's been the goal from the beginning, right? Like, you start a YouTube channel, you want to try to see if it can pay you, right? And I'll have you all know I'm making tens of dollars a year now. So, yeah, big deal. So yeah, thank you, everybody. I appreciate it. It's really cool to kind of see the channel continue to grow. And now I guess the next goal is just, I guess, keep growing, right? See how far we can take this and where it goes. So hang out for the ride, and I appreciate you guys more than you know. So let's get to Adams and keep working. Just keep doing the thing that brought you here. All right, we are back out here at Sprague & Built Customs. I just carried in all that stuff that needs to go on here. The goal right now is just to get the harness laid out and hooked up to a couple things so that we can start checking functionality on lights. And then when I get the high power stuff, we'll start working on getting the engine fired up. Because the goal on this stage of the project, get this thing running and driving so we can shake it down. I don't need to worry about things like the HVAC or the radio, speakers, stuff like that. It's mainly just engine, transmission, and indicator lights. So if you were watching that time lapse, you saw Adam came out here. He's not feeling well, and he told me that on top of him being really sick, his heat quit working. So I'm gonna try to figure that out for him. It is currently 44 degrees in here, and I'm about to switch it over to heat to see what happens, because I think I figured it out. Let's give that a look. All right, so first thing I did was check continuity across the differential pressure switch, and if you can see it, that little plunger is moving back in there right now, and the switch is following it. So that is working, and I checked continuity, so like I know that there's continuity across that when the fan is running. So that fan right now is running, and what we're seeing is 121 volts at the igniter. That thing should be glowing bright red right now, and it's not doing nothing. Unfortunately, I don't think this is anything I can fix right now. It's not something I can just like knock the dust off of and make it move again. So unfortunately, Adam's gonna have to go find an igniter, but hopefully that's readily available somewhere. But regardless, we figured it out. So it's got a burned out igniter. Anyway, I'm gonna get back to work. All right, so we got that connector on down there. That'll get mounted up later, it's just hanging. Don't worry, but we're not gonna be able to test the entire system because, like I've said 10 times, but now it's on the truck so you can visualize it a little better. Power comes from the batteries, it'll come up through here around, and then it'll come into the fuse box. From the fuse box, it goes to a smaller fuse that then goes in through the firewall, through the IP1 connector to the headlight switch on the dash. Then it comes out of the headlight switch and goes down to the bright switch. This is where we're going to be able to start testing the system. We'll hook power to the bright switch, simulating the headlight switch on. Then it goes from the bright switch over to the lighting control module, then comes out of the lighting control module and goes up front to the headlights. So that is what we're hoping to test. Let me grab the trusty old power supply and a couple leads and we'll give that a try. I haven't tried this yet, and I hope it works. I should be able to switch between brights and low beams right now with the way this is set up. And then I may try to play around with the turn signals. If I can, I'll put this clicker in line. We'll see. I'm gonna give it a try. All right, here we go. All right, I can't tell if that's high beams or low beams. We're gonna give it a shot and go to the next option. And it works. Oh yeah, baby. All right, so the high beam switch works. Okay, now, I'm gonna turn the headlights off. Accessory, I'm gonna run this to accessory. Should bring on the halos. Now, what we're going to try to do here is I'm going to apply power to that lighting control module. What should happen, this halo should go out. The daytime running light should go out. That one should stay on. This one should turn orange. Now, it's just going to be solid for now. It's not going to blink yet, but it should switch from white to orange, basically. So the one halo goes out, that's good. And bam, it turns orange. Yeah, it's like a turn signal, and then once turn signal's done, back to white. You wanna see the right side? All right, I'll do the right side. Right should go out, and then turn orange. And then once turn signal cancels, back to white. Get the idea? All right, now I've got the turn signal clicker in there, and I'm gonna see if I can make it pulse properly. Now again, I'm doing this holding like 5 different wires to one alligator clip, so it's not pretty, but if it works, that's a good sign. That's cool, right? So the right side should behave all the same. And honestly, I think that proves out pretty much everything that functions up here, right? I mean, we can hook the right side up. Let's try it. All right, so it's a cob mess down here, but these 2 wires right here are turning on both banks of relays in that box, connecting this thing to ground through the lights, which is making it pulse. So everything's on right now. And you have hazards. That's a nice function. So, I'm gonna make you watch this. When I unhook those wires, everything's gonna go back to white. So from the minute you turn the ignition on, that's what you get other than in start. When you turn the ignition to start, these shut out, engine starts. When you release the key, these come back. Otherwise, what you just saw is the function you get with the halos and the watermelon lights for that matter. Absolutely awesome. So, that'll do it for tonight. All right, new day, same shirt. You guys know the drill. You kind of saw we're working on this section of the harness. What I'm going to do now is kind of show you where we're at, what we're going to try to get done today. So kind of the goal here is just kind of keep working our way back, which means we're going to continue working on this branch of the harness here. You guys saw we got the tilt nose done. All the lights worked. Oh, I need to put the plugs in there. And I forgot the very specific self-tapper you need to mount this bracket. The mat is going to mount right there. And it looks really clean. Everything clears. And I'm probably going to wrap this in some more tape just to kind of protect it from the elements and stuff. But anyway, tilt nose is done. Lights work. Everything's good up there. What's left in here is the ground for everything in this branch of the harness. The horn, which we don't have the horn yet, it's going to mount right there. Super easy install. That can be done anytime. It's not critical. From there, it's the stroke sensor. We have 3 wires here. Got to put a connector on that, and then that will go to a little jumper harness that has the proper, I think that's a Delphi connector that goes into the actual stroke sensor. So they'll all have a somewhat short, some will be longer than the others, but a short sub harness that goes from this connector to my connector. We'll get to that. Then front underglow. So we'll put the 2-pin connector on that we need. Will you focus, please? No? All right. So we'll put the connector on that we need, but the underglow is not mounted yet. It's going to go right up front and center on that subframe down there. But this is the most complicated part of this section of the harness anyway. So that lead is for the engine fans. And when I tell you that these engine fans have got a lot of power, that's an understatement. I think one of those is capable of cooling this thing on its worst day. But anyway, it starts here at the ground. So everything in this branch of the harness comes to this ground. Then that ground comes to one of these 2 wires. I'll do continuity check and mark them, but we'll call it this one. So ground comes into the fan here. What's interesting about these fans is they have their own like internal controller. They're brushless and they're pulse width modulated capable. But we're not using pulse width. So what that means is we can actually run constant power to these. So this wire comes into the fuse box and has constant power, 1 on each bus bar to kind of distribute the load. So both fans have constant power, constant ground at all times. This little wire right here gets constant power essentially from a switch, and that switch will go in the engine head either here or here. I'm not sure which one exactly, but I think it's going to go in here. So we'll have ground coming into that switch and then ground coming out of that switch. It will go around the other side of the engine and we'll end up down here in this area coming through a connector that will then come up through this branch of the harness, and then we'll come into the fuse box and we'll ground a relay. The other side of that coil has essentially IG2 power, but it's a little bit more complicated than that because of the start procedure. So we'll explain all that when we're explaining how the start works, but essentially we have a ground coming from that switch to a relay in here. That relay has power, and when it turns on, it supplies 12 volts to both of these and turns on both fans without having to switch on high current. So that relay will last forever, not having to switch on essentially what is like 48 amps. So there you go. And we're able to eliminate 2 relays down to 1. Hopefully that makes sense. Ground coming into relay with controlled power through 2 other switches turns the coil on. The coil then turns on the switch that applies low current, like 3 amp power to these guys, tells these fans to turn on that already have constant power and ground, and then the fans control their own ramp up. They have like kind of like a slow start, like a soft start, and they start out really nice and peaceful, and they're really, it's almost serene, and then all of a sudden a tornado starts coming out from underneath the truck, and everybody's running for their lives. So if you need some incredibly powerful fans, get on Jags and buy the Proform brushless. All right, fine. Yeah, no, I'll show you. That's fine. No, I'll risk my safety to help you understand. That's fine. Yeah, let's do it. Don't have to tell me twice. So we'll test the circuit like this later, but essentially I've just got the power supply hooked up, constant power, constant ground, and it's on. And you'll notice that the fan's not doing anything yet. Well, that is because this little guy needs connected to constant power and tells it to turn on, which is essentially what the relay in here is going to do. And here's what happens. Nice and serene. Oh wow, it's really ramping up. Uh-oh. You can tell just with the sound of the microphone, there's a lot of air coming out of that. And there's 2 of them. And that is drawing 21 amps on its own. There's a lot of cooling power here. Then you release that, relay turns off because the switch turned off, and then they calm down. Had to wait for it to come down from 400,000 RPMs, but yeah, that's the fan circuit there. Cue the music. In. It's not, I don't have an eyelet for it yet, and then it will get tethered right about where my ring finger is, and will come up and over, go into the harness, and that's what she'll look like. Front firewall harness status report. This guy's done other than being mounted. This guy's done other than getting an eyelet and being tethered. A horn, don't have one. This is the other side fan. I don't have another DTP connector. I thought that I had more DTP2s, but I don't. So I'm gonna order some of those and order the bullet connectors I need for the signal wire. This side of the underglow is done. And the stroke sensor is done on the firewall harness specifically, and then you just saw me build a little sub harness. This is the connector that goes to the stroke sensor, and this is the one that goes to my side. Here's why I did this. So you can see the stroke sensor down in there, and you can see its connector right there. You'll notice it's loose right now, and that is because this connector just has a really simple clip. You lift up on that little tang right there and it comes loose. The detent for this is facing the chassis. So in order to unplug this, you have to loosen the stroke sensor and pull it out so that that thing can clip like so, and then you tighten it back down and you can't get it off. So for ease of maintenance, repair, whatever, modification, I put my connector on there, so you only have to unplug this one to get the stroke sensor unplugged from the truck. Rather, you know, if you got to replace it, it is what it is, but you're taking it off anyway. But this makes it easier to unhook it when you're working on the truck. So I'll plug that in, and that is about as far as I can go at the front of this firewall harness until I get a horn, an eyelet, and some mounting screws, another DTP connector, and bullet connectors. Okay, so we'll tether that up a little bit, and then the next thing I need to do is, I had a little bit of confusion in the bottom of this fuse box about the air ride constant and air ride switch power. So I think I labeled them backwards on accident in the fuse box, and that's where this is coming from. So I had a note to double check that on the truck, because in these connectors down here that go to the rear chassis harness, it is correct. So just need to double check that and maybe fix a little snafu in here. All right, so I've been making some progress on this thing. Didn't really record it. I don't know what it is, man. It's difficult to like record while you're working and like think about what would be interesting and then do it at the same time, if that makes sense. Moving the camera around kind of is a bummer, because there's like literally no good place to sit that little tripod on this thing. and you kind of get on a roll, you just keep moving. So anyway, sorry, didn't record some stuff, but here's what happened. So since I changed up my logic in the fuse box from having one of these stainless studs right here, instead of having one of those be switch power from a giant relay, I ended up making them both constant power, which means I had to move the trailer charge and the wiper feed from the bus bar directly to the switch to a relay in line, because you don't want those to have power when the key's off. So they now have logic that's controlled by the key. I also kind of just decided I was going to keep moving back through that harness, and since the lights are in the front, I decided to kind of confirm that all the lights worked, even though it's at the back of that harness down there. Listen, there's logic behind my madness, but the point is, I made my way into the cabin after I plugged the rear chassis harness in, and here's why. You saw me playing with the lights the other night. What I was doing was jumping the 3 wires that go into the bright switch here to make the lights come on. So what I'm working on right now is kind of getting all of that tied up. Now, instead of applying power to the brights and the low beams here, I can apply power to the center feed wire to the switch, which comes from the IP1, which comes from the headlight switch. So essentially, this system is ready for the dash to be put back in. But what I'm working on right now is getting grounds put in. So I had to put in a ground lug right there, or I guess a ground riv nut, if you want to call it that. And I'm going to pull the steering column down here so I can get a hole drilled to put in a riv nut underneath that so I can mount this. It's just kind of been floating in here, and it would be nice to get it mounted. So working on installing riv nuts right now. There's been a lot of talking in this video. I hope you guys like it. I've heard from more than a handful of people that they like all the details kind of being shared. So that's what we're doing, sharing details. So yeah, you're gonna see from about this angle right here, I'm gonna drill some holes. All right, so today was a good progress day. We got a lot done on this thing. We got a lot tied up in the front half of the firewall harness, and then quite a bit tied up under the dash. There's still a ways to go there, but we've got the power supply on the front left tire here. It's running power to both sides of the fuse box, so it is acting battery right now. Now, we can't power up any of the big stuff like the fans because this thing just can't handle it, but we can run up to about 30 amps. So what we're gonna do now is shut the hood and test the lights. All right, so I've got the shop lights off. What we're gonna do is I'm gonna turn on accessory switch, and we should only see halos and radio. Then I'm gonna switch to IG2, and we should see halos, radio, and hear the relays in the underhood fuse box click. Then from there, we're gonna turn on the running lights, and you should see the watermelon lights pop on, and the rear bumper lights and rear tail lights. In the future, when I get the cab lights hooked up, they'll also come on, and so will all of those front bumper lights. There's 29 of them that gotta go in, but we're just not worried about that function yet because it's not critical to drive the truck. From there, we're gonna check the low beams, then switch to the high beams, check those, and then I'm going to turn them off so that we can see the daytime running lights better. You don't want your headlights on to see the halos because they're daytime running lights, daytime no headlights. Then we're gonna check left turn signal, right turn signal, hazards. If all of that functionality passes, we are done for the day. All right, first things first, let's check the accessory mode. We should get halos and a radio. We got halos and the radio's on. Now we'll switch to IG2. The only difference here is we should hear the relays underneath the hood click. Got them, and the radio's on. So this is what the truck will look like in its running state with no other lights on. So this is exactly what will be happening while the engine's running. So that looks good. Now we'll try the running lights. We should see the watermelon lights, the rear bumper lights, and the tail lights. That's what we got. Later on, there will be 29 lights in this bumper that come on as well, and the 5 cab lights. So we'll get to those, but I haven't run the wire across or the wires down or any of the lights in the bumper yet. So those will come on just the same, so we can be pretty confident those will work. Now let's try the low beams. That is your low beam setting, and then in order to switch to the high beams, we have to kick the floor switch. That's your high beams. Low beams, headlights off. Then we can check the dome light. Dome light works, good deal. Now we need to check some of the functional lights. We're going to check brake lights first, so keep a good eye on the garage door. Then we'll check the left turn signal, the right turn signal, and then the hazards. So as you can see, the brake lights got much brighter, so they're on. And we're going to leave those on to check the turn signals, because when I turn the turn signal on, what should happen is power being applied by the turn signal lever should actuate the relays in the lighting control box. We should see this halo go out and then start blinking orange, and we should see that tail light, that brake light, start blinking. So as you can see, the white halo went out, the orange halo started blinking, the watermelon light is blinking front and rear, and the brake light itself is now blinking. So left side functionality is good. So let's check the right now. All right, now as you can see, same functionality on the right side. White halo came back over here. White halo went out over there. Watermelon light's blinking. And I don't know if you can see it from that angle, but the right brake light is now blinking. So the only thing left to check at this point is to put the left in there as well and check the hazards. And there you have it. Full functionality out of the lighting control module. Everything's good. All 3 relays each side and 2 fuses on each side are good to go. We're at 4 amps. Pretty efficient system. Let's go ahead and turn on the headlights as well. And the dome light. And you know what? For funsies, we'll turn on the high beams. See what kind of load we're dealing with now. We're hanging around 10.3 amps to run all these lights. So while we're working on this, I decided I ought to check these. You know, this is part of the turn signal system here. So put the combi meter back in it and it looks great. So the running lights are on right now, but turn them off, lights go out, and the running lights back on. And then if you rotate the headlight switch, you can actually dim these. And it's not really showing up very much on camera, but like that light I can barely see in person, and it's getting brighter, 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 and then the dome light comes on. But yeah, there's quite a delta when you're looking at this in person. The phone didn't show it very well, but anyway, these don't have all the inputs run to them just yet, but if we turn the key on, you'll see them do their self-check. Voltage is reading, which is accurate, and the TAC and speedo did their self-check. So then the radio's on. So that's pretty cool. This one's pretty nice because everything's run through that connector right there. So in order to get these out, you just unplug that and you just pull these gauges all the way out. I'm gonna go ahead and call it there today. I've seen enough blinking lights for a while. So that's it. See you on the next one.